Hi, I'm Greg from Christmas at the Hormans. If you've seen our display, you know that we have a lot of interactive features, such as the ability to text your name to be included in our large overhead grid, or logging into our website and participating in the voting process to help select the next song. A few years ago, I saw this interesting video from Victor Johnson at Lighting Up Paxton. Victor set up cameras to monitor the power consumption of his entire house and then synchronized that video to his display. Now, Victor uses over 140,000 incandescent light bulbs that, if all on at once, could pull a staggering 600 amps. Now, he has to carefully plan out his display to ensure that he never turns on more lights than his wiring and handling can support. Now, if we look at our display, things are a little different. Our display leverages some very efficient pixel LEDs, but we still have a large number of questions come up about how much power does our display consume. And this got me to thinking, what if we had a device that showed the near real-time power consumption of our display? Maybe a readout positioned right above the garage. So I started to investigate if we could do something like this. After a bit of research, I came across the ACS 712 current sensing boards. By monitoring the magnetic field produced near the wire, these chips can reasonably accurately measure the amount of current flowing through a wire. Now, for alternating current, this could be a bit of a challenge, but I found a very nice method that involves taking samples every millisecond along the sine wave for 500 milliseconds and then using that information to calculate the total power consumed. What I'm about to show you is our first workbench concept to test this theory. In order to ensure that sampling occurs at the required frequency, as well as to do some minor math, I'm using an Arduino Mega. An Arduino Uno would also work here, but I chose the Mega because it has 16 analog inputs versus the 8 on the Uno. Our display is powered by 4 20-amp breakers. Now, per spec, each sensor is supposed to be able to handle 20 amps, but after looking at the size of the pass on the board, I personally don't think I'd push them much beyond 10 to 12 amps. Still, for our display, this works out well. Our 20 amp circuits get broken down into 12 extension cords that carry the power outside to various locations. No cord will ever pull more than 10 amps at its peak, so really 12 sensors would be the right amount. So how do we get this information from the sensors and into our display? Well, with the Arduino Shield, we can transmit this information over our wireless network using the MQTT data bus, and then send the information to both our website as well as a custom C++ program that controls other elements in our display, such as the snowman and the large countdown clock. From there, we should be able to leverage the same technology that we see in the clock for digitally displaying the current power being consumed. Now, while we have a lot of work to do to make all this happen, you can see in this first test that the sensors seem to be working well and publishing data via MQTT to my laptop. The one is measuring 6.7 to 6.8 amps. Now, right beside it, you can see that I have a kilowatt sensor that is measuring around 6.7 amps of draw. Not too bad for these inexpensive sensors. So while we still have a lot to do to get fully ready to the show, I wanted to just kind of show you what we had it in mind. If you're interested to see the sketch for the Arduino program, it's already been published on Bitbucket. Stay tuned to see how this project progresses.